problem, we're going to take a look at maximizing area. Find the area of the largest rectangle that can be inscribed as shown in the triangle. So we've got a triangle here, we've got some points, x and y intercepts there for that hypotenuse, and then we've got a rectangle in here. We need to maximize the area of that rectangle. All right, so I think the first thing I'm going to do is take a look at this hypotenuse, and I'm going to write the equation of that line. We can clearly see that we've got a rise of 3 and a run of -4. So my slope for that line is -3/4. All right, well, right there's the y-intercept. So my y-intercept is 3. So if my y-intercept is 3 and I know the slope, then the equation of that line is going to be y equals -3/4 x and then plus 3. So I've got the equation of that line. Now the next thing I'm going to come down here and do is I'm going to take a look at this rectangle. Okay, this point could move along this line, which would change the dimensions of that rectangle. All right, we want the largest rectangle, the area of the largest rectangle. So I need to represent this generically. If this is some distance x and this is some distance y, all right, then that point x, y, that corresponds. So x times y is going to be the area of that rectangle here. So let's just do A equals x times y. So there's my area. Now, if I'm trying to maximize this area, I need to write this equation as a function all in terms of x. All right, well, right now it's in terms of x and y, all right, and not written in function notation. So I'm going to switch this to function notation, a of x. All right, it's going to be x times y, but I need it to be x times something else written in terms of x. Well, I know what y equals. Y is -3/4 x plus 3. So I can do -3/4 x plus 3. Okay, now I'm just going to manipulate this equation here. Let's go ahead and distribute that x. So then I'm going to have a -3/4 x squared plus 3x. All right, at this point, we want to take our first derivative. So a prime of x. All right, taking the derivative right here, I'm going to have a -3/2 x. Taking the derivative on that 3x, I'm going to have a 3. Now, once I get there, I can set that equal to 0 and solve for x. So -3/2 x plus 3 equals 0. We'll go ahead and subtract 3 from both sides. Actually, it's probably going to be easier to add the 3/2 x to both sides, so then I've got a positive on both sides. So I'll have a 3 equals a 3/2 x. All right, and then solving for x, we're going to be down to x equals 2. So now I've got an x value that's going to maximize this. Now I need to find my y value. So I'm going to come back, I'm going to use this equation, y equals -3/4 x plus 3. Since I know what 2 is, I'm going to plug 2 in. Y equals -3/4 times a 2, and then plus 3. Doing a little bit of arithmetic there, I'm going to have y equals a -3/2 plus a 3. Give me a final value of 3/2. So y equals 3/2. So now I've got my y value. That gives me my maximum value. The question wanted find the area of it. So I know x, I know y. So if I'm going to calculate my area, then I can just do 2 times 3/2, which is going to give me a maximum area of 3. So straightforward there, a maximizing problem using a little bit of calculus. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.